Good evening, Professor. This is my personal timetable. So, in this week, I have to do some literature survey as well as to think about the new process and also working on the existing P6 chip. And so, here I have make one table of content first to go with my presentation. So first of all, I just want to give the detailed chip functionalization process, and then afterwards I will go through the electrochemical deposition process onto D5 and P6 that I already did. And but in this week, uh, I have booked the machine of the electrochemical machine on Friday from 12 to 6 p.m. and the mechanism of deposition process and the chip fabrication process steps and the P6 fabrication results and D5 results as well, and also discussing about the future plan of my this process, and also give the brief introduction about the what different type of electrochemical machines in the market and what are the basic things in these machines as well, and why we are preferring the electrochemical method instead of the our existing methods for the deposition of the first layer like graphene oxide as a carrier. So so now it's a this one is the future plan using this P6 chip, as I have just one changes in there, like to first using the electrochemical deposition method for the graphene immobilization. So this method is basically it takes 20 minutes or 25 minutes for each chip. So on Friday I booked from 12 to 6 p.m. It's like 6 hours. So if I calculate for each chip like it's like 25 minutes for like maximum half an hour for each chip. So if I say like 12 chip is possible for the electrochemical deposition, but it's and trying to um, make more and more chip for the deposition for this one. And so it's a normal process is already explained before. So I do not take so much time for this. So it's washing and then EDCNHS and then afterwards again washing and then afterwards and immobilization of antibody and then BSA as a blocking method for the unwanted antibody onto the surface to just peel off from the surface, and then afterwards using BBS for the normal washing, and then we use antigen and then afterwards washing with the BBS and then be measured. It's a serial kind of steps that we have to follow for this process, and for this process each process we have to measure the capacitance value using the impedance analyzer. Sir, as per your suggestion, I have made this detailed chip functionalization process. Is using this process in the future and as well as in by today also. So the thickness of platinum on titanium is like 0.15 micrometer, and then afterwards like if we go with the second step one, so we just doing the step one is like piranha cleaning, and then afterwards washing with the DI water and ethanol, and then afterwards immobilization of the um, graphene oxide via electrochemical deposition. So if here I just make the clear visualization, like after electrochemical deposition the graphene is stick or like to you know stick onto the SiO2 surface. Is an open surface in between the fingers. So after washing with the ethanol, so graphene is totally deposited on in between them, and it's electrochemical deposition. So there is no as such chance after washing the graphene oxide is removed or peel out from the surface. And then afterwards we use EDCNHS for the drop casting. So here I just make like if we use drop casting, so there is a chances to deposit onto the platinum surface. So but after washing with the ethanol, so our EDC just only onto the graphene oxides bonding with the graphene oxide, and then afterwards we put the antibody immobilization via drop casting method. So here also make the serial like the antibodies overflow onto the whole surface area, but afterwards BSA, so BSA is also whole surface area, but after that washing with the PBS, platinum content like onto the platinum content is peel out from the surface or like wash out from the surface. Only the active part is like EDC NHS, and with the antibody is only stick onto there. And but afterwards is the antigen immobilized onto the surface by drop casting method. Also the same condition like the platinum onto the platinum also having some antigen content, but after washing all the platinum content is removed, and effective like the bonding between the antibody and antigen itself present onto the surface. So this is the schematic visualization that I have made, and we have to follow this process in our biosensor group. And it's just a physical phenomena that occurs in the whole process. If you say like to make a chemically bonding schematic figure, so then I will proceed that. So this is the physical schematic visualization. So afterwards it's another detail uh, chip functionalization process in terms of the timing, like how much time it will take for each process. So I'll make it here. So for the piranha up to the GRO it takes like 1 hour for this, and afterwards it's like um, 10 minutes for the EDCNHS, and afterwards washing with the ethanol and antibody mobilization. And then BSA it takes for 5 minutes for washing, and then after antibody and antigen, or like after washing with the PBS, antigen is immobilized onto the surface, and it does not take more than 10 seconds. It's like milliseconds attachment between them, and this whole process is approximately 80 minutes, or like 75 minutes or 10 seconds. So this is the whole process in terms of the timings. So last week I went there to for the electrochemical deposition. So here is the snapshot of this whole system, or like machine. This machine is having the three different kind of electrodes itself to measure with the machine, like EIS machine. So these three electrodes is compulsory for the electrochemical measurement. So first is the electrode. First electrode is like counter electrode, and the second one is the reference electrode, and third one is our electrode, like working electrode as our D5 or P6 chip. So yeah, previously I did 5D5 chip and 10 P6 chip, and I'm pretty much sure like P6 is much better than the D5 because of the deposition of the graphene is higher than the D5, because the two things like the in between the fingers having the large surface area, large surface content in between the fingers, and also the large surface area of whole chip. So this is the positive factor of the P6 chip. So in this week on Friday I will go with the P6 chip and measure and use this chip for the electrochemical deposition instead of D5. And obviously it's a graphene oxide aqua solution I have to use as an electrocatalytic probe. So this is the main whole setup of this whole electrochemical mechanism. So as I mentioned here, is our chip is act as a working electrode, and the platinum wire is a counter electrode, and the AgCl based reference electrode. So these three electrodes are responsible for this whole process. So it's D5 chip having PITP metal finger dip into the graphene solution called electrocatalytic probe, and it takes 15 minutes of each deposition, but it depends how much cycle we have to run. So normally I use previously 10 cycle. It takes 15 minutes, but I'm considering now is like 15 cycles. so it takes more than 15 minutes, so approximately it's a 20 to 22 minutes for each chip for the deposition. So it's the chip fabrication process step. So I just have to skip one, but before this to skip, I just want to share my the measurement criteria. So the scan rate of this machine is 50 millivolt per second. Number of cycle repeated is like 10, but in this week I have to use 15 cycle because of the thicker deposition of the graphene. So I have to go with the 15 one, because last chip we got we use the 10 one, so the thickness may be it not suitable for our chip, so we need more thickness, so that's why I just want to exceed the cycle. So in this week I have to use the machine, so using the 15 cycles in each chip, and the maximum current is like 1 ampere, and the voltage is more than not more than 10 voltage, and the ES frequency is 1 millihertz to the 10 microhertz. So after that, after the deposition, I have to use the hot plate for the annealing process, and then wash with the ethanol, and using EDCNHS for the immobilization, amide bond formation after that, and then hydrogen bonding, amide bond, washing with the BSA, and afterwards normal washing with the PBS, and then antibody antigen complex combined in a milliseconds or not more than 10 seconds, and then washing with the PBS and drop by drop method, and then we have to measure the capacitance in terms of different concentration of the antigen. So this is the result of the previous chip that I use in terms of the electrochemical deposition. So you can see here the slightly transparent deposition over the surface, so that's why I just want to exceed the cycles of the machine, so that we got the thickness, also more thickness of the graphene oxide. So because if we get the more thickness, then consequently we have to use the washing. So maybe it's a point minor graphene is also washed from the surface, so itself having the graphene onto the surface, so that our chip is having the stability as well as also produce the stable value in terms of capacitance. So that's why we got here the very less value, because of the thickness of the graphene oxide is not uh, as much as I thought. So that's why I have to exceed the cycle as well. So this is the result. So some of the chip is not working well because of the not deposition equally distributed onto the surface, but according to this value is all the value in terms of the picofarad. So I have to if I increase the thickness of the graphene oxide, so maybe that the value goes into the nanofarad, as I already did before by the using the our conventional method as well. So this is the D5. D5 result is not stable because of the less surface area in between the fingers, so that the graphene is not attached well onto the surface. So I have to I don't want to use this chip now for the electrochemical deposition, so I go with the only P6 chip. And yes, so this is the another process that one of the researchers did, like they used the silicon selenized glass, and then use the glass graphene quantum dots, and then afterwards they use antibody, afterwards VSA, and then wash with the PBS, and then use the anti-HRP. But as you said, like we have to use until antigen, no need to go with the further using the antibody. So this is the another example that we are going in a right direction, and this our process is already used by some researchers. So our process is right, but we have to just think about how we can stable our results, and how we can um, think more about the effective results, like that's our goal. And so this is the another paper that I have found, that the some of the researcher using this kind of chip as an electrochemical deposition using the ferricyanide as an electrocatalytic probe to just deal with deposition of polypyrrole on the surface of interdigital electrode and dipping the chemi resistor in the electrode. So they just used to presence of the potassium chloride or ferriphenocyanide to detect the hydrogen sulfide and ammonia as well. So this is the another method the researcher used. Like in future, if we plan for the go with the our chip and electrochemical method, so we just use this kind of process in future. And also after, we have the capacitance um, point of view. So we do the two things in a one with the one our chip. So this is our research future research plan for in future if we have this kind of scenario though, so we can apply for it, apply with our chip, and we can do this method, we can do this kind of research interest in the future. So here is the different kind of electrochemical machine that I already this machine this I already use in at my PhD time. So this machine currently I used in the Korea University last week for our electrochemical deposition. So there is no as such major difference, but in the case of this one is only two channel, but in this case having the five different channels in here I am going to clear like why I'm saying here it's two channel and five channel, what is the difference between them. So basically, so five channel means the five different kind of process is working at a one time, and here is only two different kind of two process is actively participate at a one time. So only this thing is the main basic difference. But if I go with the current and voltage, so now there is no slightly difference in between them. And other instrument is also having this interface specification, and having the same thing like it's a four channel um, machine. So as I already told that four channel means like four different reactions are working at a one time. So this is the main uh, things. And why we are using the electrochemical machine, because it works as a low temperature and no need the film was is obtained is highly flat and uniform. Like our main focus is to first of all we have to think about like how we can immobilized any kind of material in our surface in a uniformly. So this is the main basic method that we have to use and that we are using here now. So the deposition of the graphene on our D5 or like P6 chip is linear or uniform, and depend on the different like number of cycles we have to thick more and more and more in the complex shape and be coated. So that's why it's my main goal for using this kind of method. So reason why we prefer electrochemical method, as I already told, is more complicated. I know it's more complicated because it depends on the electrodes. And the third one is like to reproducibility and the good uniformity as compared to the spin coating or spray coating. And it takes voltage or temperature for the um deposition, and the transfer patterns that run in and across cavities, so metal patterning are preferable. So basically the this method is more better for our chip, because it's basically the electrical conductivity kind of mechanism occurs. So um, because of our metal pattern, metal fingers, the deposition is going the uniformly, and our result is will be getting the stable, and we got the stable value in terms of capacitance. So that's all, sir. Thank you.